Hello, Professor. We would like to present about the proposal of data management strategies for the global transit automated transport system. Firstly, I'd like to share with you the outline of our presentation. I will introduce more about the transportation system and why do we need a data management strategy. Then the teammates, Yiwenhui, Runze, and Ino will talk more about the DBMS we propose. Simon will talk about the business operation and profits, strengths, weakness analysis, and conclude our presentation. So for the introduction part, we know the GTA's data-driven transportation system is carried out by the autonomous electric vehicles. The public transportation system is not accessible conveniently to everyone, as we know. So the goal of this program is to improve the public transportation commuting experience. So the primary function of AEVs is to support the first mile, last mile connectivity. It is done by establishing a connection between the user's origin and the destination, which is a public transportation node like a bus stop. Then the data management system is necessary to facilitate this transportation system. The system is used to collect, store, and analyze data generated from vehicles and also other sources, and use analyzed results to support the decision-making process, like the arrangements of the vehicles and also many other applications. So to build a data management system, we need a strategy to guide and plan for us to align with the overall goals and objectives of the data-driven transportation system. So there are a lot of concerns we need to take care about when designing a strategy. Firstly, the system needs to manage large amounts of data. So coming from various sources, including internal data, like the sensor data, cameras data, GPS data, and also external data, like from other systems, like weather data, road data, etc. Also, the AEVs need to make real-time decisions based on the data they generate. So this is require a data management system that can handle large amount of data in real time and provide the necessary insights for the decision-making process. Thirdly, is the regulation concern. The use of AEVs in logistics is subject to various regulation standards, such as data protection and privacy laws. So the system needs to ensure the compliance to these regulations. Finally, the system is often a smaller part of a large system. This means that there are often other components like routing, dispatch, and telematic process, and to integrate with the AEV system. So that the data management system need to ensure the data exchanged between the systems in a very reliable and consistent manner. So let's pass my time to my teammates. Thank you.
Thank you, Michael. And then let's pass it to the database management system. And this part will be introduced by me and Runze. First, I will give a detailed overview of our DBMS to help you know how it can be implemented for the GTA. So first, let's have a quick overview of our DBMS design. All the design has been illustrated in this figure. The first part of our database management system is the data source and data collection. The data in our DBMS can be mainly divided into three different categories. The first is external data, which includes the data of like weather, road conditions, and public transport. And this kind of data can be collected through the specific APIs. And the second data source is the system application data, which is mainly from the data building, like the customer data, order data. And this data can be just collected through the files within the applications. And the last data source is the sensor data, including the GPS sensor data, radar sensor, and any other sensor data. This kind of data can be collected through the IoT technology, which is Internet of Things. And the second part is, which is also the main part of a DBMS, is how we can store this kind of data. So the main storage for our data is is a data lake. Since the data used for GTA will include the data like unstructured data, structured data, and also the data will be in a quite large amount. So the data lake will be a good option because it can help us to reduce the cost and be quite effective. The data lake can just collect the data from all the channels mentioned above to store the data. And also it can help us to process the data within itself. Because GTA has the requirement to do the transactional processing, which need to be responded to the real-time applications like placing an order, responding to the customers, and also choosing a optimal route. So the relational database is of great importance, which should be supported for the transactional processing. And the detailed information of data source and data collection and the data lake will be introduced by Renze in the next part. And then let's move to the data warehouse. Because we know GTA also has a requirement to do analytic processing because you want to know, is there like any improvement in the orders pricing, or is there like any improvement in the customer's quantity? So to support the OLAP, which is also the analytics processing, the data warehouse is needed. The data can be derived from the data lake and the relational database through the ETL processing, and then the staffs can, using the quite user-friendly interface, just like to execute some simple queries or data services to get the kind of data to do the business analysis. And the last part is about our data security and surveillance. To maintain the sustainability and scalability of our DBMS, the privacy and security software is really important to implement it within our DBMS, and also the data backup method is needed. So this is just our general overview of our DBMS. Let's pass it to Renze.
Okay, let me introduce the data source and collection in GTA system. Here is the database management system data overview. Data is the backbone of any data-driven transportation system, and for the proposed global transit automated system, a robust and comprehensive data strategy is essential. The system will collect both internal and external data to achieve its objectives of improving the public transportation experience in cities worldwide. The external data will be collected from various sources, such as weather services, public transports, and road condition reports from public APIs. This information will be uploaded to the GTA system in real time to assist with road planning and avoid traffic congestion. The internal data can be further divided into two categories: system and application data and sensor data. The system and application data will consist of vehicle data, map data, customer data, trip order data, and charging spot data. Vehicle data includes basic information about each AEV, such as make, model, and registration number. It also includes information on the vehicle maintenance, such as last service date and any issues that need to be addressed. Map data refers to the digital representation of geographical information that is used by the GTA transit system to plan the routes for AEVs. This data can include information on the roads, intersections, landmarks, and other geographical features of the city. Customer data includes information on each customer, such as personal details, payment information, travel history, and customer feedback. Trip order data includes information on the trip route, fare, and other relevant details for each customer booking. Thus, the fare calculation algorithm in the system can calculate the fare based on a variety of factors, such as distance, time, demand, and other pricing conditions, for example, discounts. And the charging spot data includes information such as location, availability, and capacity of charging spots for the AEVs. This can be collected from charging spot providers. The sensor data includes GPS data and other sensor data. The AEVs are equipped with GPS sensors, which generate real-time location data. GPS details used to track the vehicle's location and to optimize routing decisions. Other sensor data includes data generated by the AEV's camera, radars, and other sensors. Data collected is used to make real-time driving decisions and to improve the overall performance of the AEVs. After collecting this large and complex data, including unstructured data and structured data, data lake is an optimal choice to store all raw data and process data of the DBMS. It consists of raw data, history data, and a relational database to support the requirements of OLTP. Raw data refers to the data that has not been processed or analyzed and is stored in its original form. In a data lake, raw data is collected from various sources, such as APIs, sensors, and databases, and stored in its original format for later processing and analysis. Once the data is collected, it should be processed and stored in the data lake for easy access and analysis by the AI. There is a lot of data collected from data sources that require real-time updates to support the system implementation. History data refers to data that has been collected over a period of time, typically using for tracking changes and trends. Relational database, on the other hand, is a type of database that is structured in a way that enables the system to easily and efficiently query data based on relationships between data entities. It can combine with other data sources and used for data analytics and reporting. OLTP, which means online transaction processing, is a type of database system that is designed to support the processing of large volumes of short transactions. The relational database is responsible for ensuring that the data remains consistent. So next, I will pass my time to Catherine again, and she will explain further. Thank you.
Thank you, Renze. And then I will introduce our relational database and transactional processing. Because we know that the GTA has a lot of requirements regarding the transactional processing, we need to respond to the real-time applications like the placing order and also to do any kind of updates or adding or reading to getting our information of different kind of trips routes and different kind of vehicles in use. And also we also GTA wants to know the information about the customer and the payment and many other data involved. So the transactional processing is of great importance, and the relational database is used to support the transactional processing. And here, a partial ERD has been proposed to give a sample of how the data can be connected to support the transactional processing in the relational database. And the ERD here is mainly cover the business and the data involved in the trip order and vehicle maintenance. So here we can see that through the transactional processing, staffs can easily do the CRUD options to the data, like to the vehicles, or to add a customer, or to add one more order if the customer has just placed an order. So the concurrently processing has been possible using the transactional processing, and also the consistency has been allowed within the transactional processing. And let's say move to the second part in the storage for our data, which is the data warehouse, and it is supported for analytics processing. Apart from some transactional processing and the real-time applications, the further long-term analytics is of great importance for GTA, which can be used to improve its decision-making process and also to improve its service for customers. For data within the OLAP, the dimension table and fact table should be used. And here has also just given sample of the trip order. We can see that it has been in the star schema, which the trip order is the fact table, and it's connected a lot of dimension table like the vehicle, customer, driver, time and place. And then the order rating given by the customers and the price paid by the customer can be aggregated by our OLAP by the GTA staffs, and then it can be used for further sales analysis or the order analysis. So in a word, the OLAP can support the multidimensional analysis, and it can be quite flexible and interactive, which can lay a solid foundation to generate business insights for GTA. Thank you, and let's pass it to Inor to help us introduce some business operations.
I'm going to introduce the third section, business operations and profit. I will analyze business operations in various scenarios where data is needed, the dimensions and facts, how the data can be used. My teammate Simone will talk about the business applications and profit. Data can support business in at least 4 scenarios. First, the real-time traffic condition analysis, which can be used to conduct route planning. Second, the first mile, last mile connectivity, from which we design a first mile, last mile program and a supply management system. Third, for on-demand arrangement, dynamic fare management and early bird incentives can be implemented. Last but not least, for fine-tuning operations, data can support vehicle performance analysis, customer satisfaction analysis, the route profitable analysis. Because of the limitation of time, I will introduce the first 3 parts and leave the final parts in the report. Firstly, the real-time traffic condition. Business operation here is route planning, which means system can plan the best route for vehicles from the origins to destination in advance and change the route in a timely manner. Vehicle data can link with road information by time and road segment number, providing vehicles real-time speed of roads information to calculate average speed of each segment of road. System can combine map data and order data to plan several routes. Then, considering real-time road information, choose the best route. After that, first mile, last mile program. It is a service which provides vehicles to transport customers from their home to nearby railway stations. To achieve that, when a customer places an order, the system automatically matches an available vehicle in customer service area by considering the vehicle type, if there exists available seats, the distance from the vehicle to customer, the distance from the customer destination to other's destination, and then match the most suitable vehicle. Third, the supply management, for which analyst needs to plan how many vehicles will be offered for first mile, last mile service in an area. They need to predict the demands. Generally speaking, weather will affect the demands. Wet weather like rain will result in an increasement of demand of calling a vehicle. In addition, station information can tell the potential number of customers and the time of their occurrence, which is helpful in planning vehicle supply. And this is my introduce about the business operations and data use. And I will pass my time to Simone to introduce the business profit.
Thank you. So as Ino has mentioned, those 4 operations can be broken down into the 4 functions as shown below in this slide. So under the real-time traffic conditions, the company will be capable to handle critical tasks in real time and provide reliable performance. This precise reaction time can also help prevent accidents and increase the overall safety on the road. With these conditions, it can improve companies' cost effectiveness by reducing its reliance on expensive hardware components, which can lead to cost savings in the long run. Under first mile, last mile connectivity, the system will provide linkage between the EV services and the train operators to deliver comprehensive coverage. To generate profit, the fee is calculated based on the distance traveled and the time of the day, with higher fees during peak hours. Under planned and on-demand arrangement, early bookings in advance will have discounts to customers, and customers can also have access to real-time traffic information and can monitor the progress in real time. Company can expand their customer base to generate more revenue. Under the service improvement through analytics, one of the most common scenarios that an EV company can utilize is analytics to conduct predictive maintenance. The company can access to a wealth of data about the usage of its vehicles, including the distance traveled, charging patterns, and the performance matrix. By using predictive analytics, the company can predict when a vehicle is likely to have an issue need to repair and proactively schedule those services, which can greatly reduce the operation costs and ultimately increase the profit. As we've discussed about how the system works in the real life, the current database would also have its strength and weakness, as it can provide large-scale data storage and also improve the data accessibility and increase its scalability and also support effective data management and allow multiple applications for the end users to decide. It also has some weakness that will require users to pay attention to, as the system itself combines both data lake and data warehouse. So the system itself is rather complicated. It will be very challenged to debug and maintaining, and also increase the company's operation costs. It would also raise data security risk as it stores a large amount of data. It may have performance issue in the long run, as the system is rather complicated. So to sum, under this project, a database management system utilizes both data lake and warehouse were designed to counter the business problem and provide an optimized solution to assist the company's data management. And we do believe that GTA, after implementing our system, will definitely continue to grow and deliver more business force in the future. Thank you very much.